All right, so this problem boils down to find the derivative, and then we'll worry about the second part. And in section 2.8, I don't have any shortcuts. In fact, we don't know anything related to this anyway. This is going to be section 3.4 is when we're going to finally be able to do this. Or 3.3, anyway, we'll see, 3.2. So what do I have to use then? Back in chapter 2. Limit definition. Everybody's favorite. Okay, so I've got that written down here. Okay. So help me out. So let's just remind you guys the function they gave us was 1 over x squared. What was it? Minus 4?
1 over x squared minus 4.
Okay, thank you. So I've got this piece, right? What do I still need? F of x plus h. So this is what I call, not just me, this is what's called the construction approach. You see what you need to answer a question, and you see what pieces you don't have yet. Whatever you don't have yet, you construct it. So f of x plus h, what would that equal to?
1 over x plus h squared minus 4.
Yes. You don't just throw a plus h at the end. You have to plug that in, right? You guys with me? Is that what you hoped it would be? No. But we know the process. The process doesn't care. How to roll it out cares. We care. There's fractions. They need LCD, all this kind of crap, right? So now when I do this, I get f of x plus h minus f of x all over h. Everybody's very excited about this prospect. So I'll give you, well, what do you guys think? First thing you think is, my God, why didn't they put in the freaking schedule that this guy can't write? We're shit. That would have been good to know before I signed up for this. But, let me write this again.
Common denominator.
Common denominator. Okay. I always like to make people wonder, is he drunk? So, help me out. What is this missing that that's got?
X squared.
The whole damn thing. I love it. Some people say it's missing an h squared. No, this guy does not have an h squared. This guy has no freaking h squared. Right? The same way you would all agree with me that 1 over 9 has a 3 in it, it does not have a 4 in it. You would all agree with me because we know in means factor of. Yes? So this needs him and this needs him. They need each other, right? So you're going to multiply top and bottom by this and top and bottom by that. Again, this is not hard. It just looks gross because they have fractions inside of fractions. But again, it's a little bit of writing and it doesn't look nice. Who cares? You got to get over that shit. And here's a really key thing. So let me see if you guys are cool with this. Let me write down here. On the top, so is everybody with me that I'm going to have x plus h squared minus 4 times x squared minus 4 on the bottom? Is that cool? On the top, yes?
Yes.
The bottom of the top. Clear as mud. What's this going to get multiplied by?
X squared minus 4.
Minus, and what's this going to get multiplied?
X plus h squared minus 4.
I love it. As is clearly demarked here. What have I left out? Yes, and here's what you can do. Bam. Bam. Because this whole thing is being divided by this shit and this shit from the beginning. So just put all this shit on the bottom. Don't make a big deal of it. Isn't this equal to times 1 over h? So what the h just joined the stuff on the bottom? Make that a part of what you know. You know that when you divide by something, it's times 1 over that thing. So of course the h just ends up there with everything else. This is instantly much better. It's still not fantastic. Do you see a lot of stuff's going to happen once you FOIL this business out? You just got to be careful with your negatives. You got to distribute your negatives through this whole thing here. Yeah.
Would that just be their
The 1 over h? Yeah, totally. Division by h, division by anything is multiplied by the reciprocal. Yeah. So that h, whenever you have fractions on the top, the h just sort of like comes with everything else on the bottom. Because he's on the bottom. Yes?
Can't you just plug 0 in for h terms?
Hell no. Can anyone tell me why not? What happens when I plug on the bottom? What do I get if I plug 0 in for h? 0. And on the top, what do I get? X squared minus 4 minus x squared minus 4. 0. Does that mean the answer is infinity? No, because what does that mean? 0 to 0? Indeterminate. I'm not done doing algebra, so I get it to a form that I can determine the answer. I love the word frickin' indeterminate. It currently cannot be determined. Therefore, do some algebra, maybe you can get it determined. What do I want to die? H. I love it. And again, not a life lesson, kids. Math. H is cool with being killed. It's fine. Okay. All right, maybe. So on the top, stuff's going to cancel. You're going to kill your H's, and then you'll be able to plug 0. Is that all right? So that's the first part of the problem is that. Which one was it in my book closed? 2.8 number 27, thank you. And the second part says state the domain of the function. Can anyone tell me the domain of this function just looking at it?
Negative infinity to negative 2.
Be less interval.
It can't be negative 2.
Can't be negative 2?
It can't be negative 2 or positive 2.
All right, so everybody with me?
Plus or minus 2.
Because you can factor the bottom as x plus 2, x minus 2. Is that cool? Okay. When you get the derivative done, you do the same thing. You find its domain. See if there's any difference. Do you think the derivative could sometimes have a different domain? Yeah. Oh, hell yeah. It's its own function. It should be related to, but it could definitely have a different domain. And that's kind of the point of this problem. Okay. Number one is to torture you with the limit definition because we're about to not do it anymore. So it's like, let me get you a little torture before you let go of it. But the other part of this is just, what happens to the domain? Does it stay the same? No. Not necessarily. Anything else from homework before we keep going? Yeah?
Do we know everything we need to know to finish 3.1 homework or not?
Yeah. Did you see 1 and 3 when that was?
Yeah, could we do?
Oh, there's one thing. There is one thing. It's kind of big. It's the E stuff. So I'm going to talk about that first thing. So which one did it have an E thing in it?
No. Could we do number 28?
28? 20. Okay. Oh yeah. Okay. I love it. So this is where some of you guys that know some calculus are going to get in trouble. We do not know chain rule yet. So this is a major thing. Everybody.
Can we use a chain rule?
Hell no. You can't use anything we haven't officially learned in here. So I don't care if you know L'Hopital's rule, and thankfully I didn't see anybody using that on limits, because L'Hopital's rule is awesome, but we don't know it yet.
But can't we just do power rule and bring it down and then multiply that by?
That's the chain rule. We don't know it yet.
Oh.
Yeah. So this is a major note. Whatever notes you're taking, maybe it's all up here. I don't know. Some of you guys have no pencil, no paper. No. Neat. Whatever way you want to do this shit, it's up to you. Right? School's better with pencil paper, but fine. Before you do calculus to any function I give you, can you simplify it? Is there something I can do? Now later we're going to learn a neat rule called chain rule. I already talked about it. I haven't told you what it is yet. That we don't have to do what we're about to do. But we don't know chain rule yet.
Foil it out.
Foil it out. Yeah. Write it twice, foil it out. Then you'll have separate little power rule pieces. Okay.
Would that be the answer? Like,
Well, I mean, foil it. Now here's a big thing too.
what was the question?
Dear God. Watch this. I'm going to make a mistake. You ready? My first mistake was not keeping track of my pen. Let's see if this works. Yeah. Everybody ready? You see a mistake I made?
Yeah, that's not good.
Good! Alright, don't do that just because your brain's going to go, we're doing something. It must be prime.
just the
No, I just rewrote the damn. I haven't taken a derivative yet. Yes. Okay. Good. Everybody see that? I haven't taken a derivative yet. I've just multiplied it out. Yes? Is everybody cool with how I multiplied it out?
Yeah.
You never know. I could go insane at any moment. Right? Oh, that makes me feel good. Thanks, John. I could suddenly forget all math. Right? But I did that right. So now I can take a derivative. So if you put prime, just because you did something, you're going to think you already took a derivative. And then things are not going to go well. Now you can take a derivative, right? So you're not done with the problem. Okay. Is that all right?
When we do a derivative, do we have to do the plus c?
You're thinking about integration.
Okay, that's different. Okay.
That's different, yeah. That's going backwards.
Oh yeah.
If I tell you I took the derivative of something and got 0, do you know what I took the derivative of? Can somebody tell me what kind of thing I took the derivative of to get 0? A constant. So yeah, when we're doing differentiation backwards, then we'll have to cover our ass for there might have been a constant there that got lost. Because the derivative of any constant, let me try this sentence again. The derivative of any constant is 0. Cool. So when I'm going backwards,
Oh, okay.
yeah, I'm going to have to put a plus, but that's in our future. Don't worry about it.
The future. We can't know about the future. That's time paradox.
Exactly. The whole thing about are we in Back to the Future rules or are we in, I don't know. TVA rules? What rules? All right, guys. Anything else? One more stuff. Yes.
66.
Is that that one?
This one here? All right, so quick definition. Did anybody try this problem and look up what normal means?
Why?
What does it mean?
Just straight up give me the normal line if it was negative over negative 2. We just
So let me ask you this. If one line has a slope of 1/3, the perpendicular line has a slope of
3.
almost
Minus 1/3.
-3. So parallel lines are completely the same slopes. Perpendicular lines are totally opposite. Change the sign and flip it, right? Do both inverses. Normal is just another name for perpendicular. Yes, kind of.
So we had to like find the slope and whatever that was. We flipped
So
it.
if you get the tangent slope, if you get the derivative and get the slope at the point, you get 1/3. What's the slope of the normal line? -3. It's the perpendicular to that. So it's just one extra step. If I say find the tangent line, you would take the derivative, plug the point in, get the slope, blah, blah, blah. If I say find the normal line, take the derivative, plug the thing in, get a slope, take its negative reciprocal, and then blah, blah, blah. It's just one extra step to make it perpendicular. So normal is just another name for perpendicular, whereas tangent is kind of like another name for parallel. It's going in the same direction. Okay. Normal is going in 90-degree angle direction. Okay. Maybe. Is that what the problem was with that problem or no?
Yeah.
The definition? Okay. I don't blame you. Okay. Yes?
Would that be like a bonus question on the next
No, normal is now an understood thing. Now I can feel free to ask you to find the normal line. It's just find the tangent line, but make the slope the negative reciprocal. That's all it is. So now make normal a part of your definition base, your lexicon. If anybody's got to take Calc 3, you'll be doing a lot of stuff with normal lines. Yeah.
It seems easy. All the lines are normal.
I don't know. Normal can get pretty freaky, actually. All right. Appreciate that. Okay. Calc 4 is where you get abnormal. Yes. I'm Joe.
Can you give us like another quick example of like a normal line question that you could
Oh, okay, sure. Let's see. So it would look exactly like a tangent line equation, except I'll use the word normal. So like, I mean this. Find equation of the the normal line. Oh gosh, today's a good day for writing. By the way, I'm gonna write this. This is EQN like that. That means equation. It's just a quick way to write an equation. The less I have to write, the better for everybody. Find the equation of the normal line to f of x equals x squared minus 3x at x equal to 2.
Could you like erase that stuff on there?
Oh yeah, I'm sorry. Just remind me, I don't do it on purpose. I just don't like the overhead. That's so what's the first step? How do I find the slope? Derivative. And what's the derivative?
2x.
Kicks so much ass, right? Derivative of any polynomial is easy. I do not care how big the power gets. The derivative of any polynomial is easy. Just a bunch of power rules, right? Okay. What do I do from here? Plug a 2 in, and you get 1. Didn't do that on purpose.
Find what?
Sorry. Find the equation, like I said earlier, EQ with a little n means equation. Just a quick way to write equation. That's the slope of the tangent line, yes? So what's the slope of my normal line? Good. Flip it, 1,
Yeah,
make it
one.
the opposite sign. So it's just one extra step. Now how do I find the equation of the line? I know the slope, yes, I know the slope. What else do I need to know? Yes, I need to know a point. So what's f of 2? 4 minus 6, negative 2. So now I got a point, check, I get the slope, check. You could do mx plus b, you could do y minus y1 equals mx minus x1, right? Okay, we all need to be cool with this shit. If I ask you to find the equation of any freaking line, I don't care, any freaking line, what 2 things do you need?
The slope.
Slope, point, yes? If that point happens to be the y-intercept, kick ass, because then I know b. If it's not the y-intercept, who cares? I can solve for b, I could use y minus y1, I could use one of those 2, yes? Yes.
So if the original slope was, like, not the normal line slope, the actual, like, derivative slope?
Sure.
Yeah, so, like, let's say if, hypothetically, it's 1/3,
Sure.
how would you write the normal line slope?
So again, a perpendicular line, which is really what normal means. The slopes are negative reciprocals of each other. So if you know one of them, you flip it, change the sign. So if one slope is negative 5, what's the normal line slope? Positive 1/5. That's all there is to it. It's crazy. Kind of makes sense. If one line's going up, the only way to possibly have a 90-degree angle is if it's the other one's going this way. Opposite slopes, yes? Now, if you don't make it reciprocal, you don't meet it at 90-degree angle. The negative makes it go the right way, and the reciprocal makes it meet at a 90-degree.
Would be more like a weird version.
Yeah. Yes. Is that all right? Okay. So this is the marriage of calculus concepts with algebraic concepts. So in algebra, you have problems like find the equation of the line that goes through these 2 points. You have a way to find the slope, and they gave you a point. Calculus, we just gave you one more way to find a slope. Derivative. Everything else about the problem is the same as it was in algebra. The only new thing is I have a new way to find a slope. Why do we need a new way to find a slope? Because I get funky ass functions that algebra didn't know what to do with. Maybe. Is that okay? So just be careful if it says normal. Are we done with this, by the way? No. So I could do, I don't know what way you guys like to do. I'm just going to do it this way. Y minus the y piece equals m times x minus the x piece. Y plus 2 is negative x plus 2. Y equals negative x. Neato. So this was the tangential slope. The question wanted the normal line. Normal line is perpendicular to the tangential. Flip it, 1 becomes 1. Change the sign. Okay.
So just.
What if I get a 0 slope? What's the
That means
normal to a 0 slope?
that means that the f is going to have
Infinite slope. Well, what's better than doing that? Put infinity in for m, which you cannot do. Don't put infinity in anywhere. It doesn't make any sense. What kind of line is this? Let me be careful.
It's vertical.
Yeah, but what kind of equation would it have?
X.
X equals 11. Which kind of, can you solve that for y? If I say x equals 7, can you solve that for y? No. That's why, because the slope is weird. Slope is infinity. Weird things happen. Can't even put it in the y equals mx plus b form. Okay. Alright, so today, what we're going to do, first thing I want to do is talk about the derivative of this function. So this is where's the variable in this function? In the
exponent.
It's in the exponent, so we call this an exponential function. It is not the exponential function, which is what we reserve for e to the x, but it is an exponential function. Can you set up how I would determine the slope of this, the derivative of this?
X to the power of x.
Oh, no. Okay. I love it. So you ready? All right, I don't blame you. If it was this, is there a rule that we have for x to a constant power? Do we have a rule for that? Yes. Can anyone tell me what the derivative of this would be? Just using the rule we developed.
Dx
b to the x, bx.
minus to the negative.
minus 1.
Yeah,
I know what you meant, Mike. I'm with you.
Okay.
It's late in the day. I got you. Right? The power comes down, goes down by 1. Is that cool? That is for anything that I can put in the form x to a number. Anything I can put in the form x to a number. Can I put b to the x in that form? Can I make b to the x become x to a number? No, it's exactly the opposite, right? The x is up in the variable now. Do I have a rule then for something that looks like that? Now, yeah, we got to develop it. We don't know what the rule is yet. Let me stop for a minute. Okay, so. I told you guys, we're going to use this to prove some things as we go along. Chapter 3 is all about shortcutting some stuff. So if I do it for this, then I know how to take the derivative of 3 to the x, 7 to the x, and 11 to the x. I can take the derivative of anything to the x. How do I set this up? Yeah, first thing is going to be f of x plus h. What is f of x plus h? b to the x plus h minus b to the x, right? F of x plus h minus f of x all over h. Now, that looks funky. Can anyone see anything we can do with this? Besides erase it and hope that I just read it.
Get rid of the bases because of the same base.
I can't get rid of them. There's nothing in there that would cancel with them. But you are thinking in the right direction. When do I add powers? When I was multiplying the like bases. Am I adding any powers in this statement? Holy shit. So how can I rewrite b to the x plus h? Where must it have come from? Yes, this is going to happen so often. And it's so easy to not realize this. How do I treat like bases? I add the powers, correct, when I multiply them? So I can go backwards. Now can I do anything? You're like, maybe you can, man, but how many terms are up top?
2.
2. Do they have anything in common?
They all have
Yes.
Yeah, what do they have in common?
they all have the same base.
They all have b to the x.
b to the x.
So if I take a b to the x out, because that's just good old GCF, what am I left with?
to the H.
B to the H minus 1.
How we doing so far? I don't blame you if right now you're like, am I supposed to know something about it? No. We're just investigating.
And this is
Yes.
3.2. No. Yes. 3.2.
This is the end of 3-1.
Still 3.
So obviously, I know where this is going. I don't know if you know this, but I know something. But this is what we would do to investigate this. The only thing we have is limit definition of derivatives. All we've got. In chapter 3, we're going to develop some more tools. We're not there yet. So when we're doing this, we just have to start there. Can you guys tell me what piece of this statement does not care about H? B to the X. Yeah. So I can actually take it out. Okay.
Oh.
Where'd you get the negative one in the step before?
Here,
Yeah.
when I take a b to the x out, right?
Yeah.
B to the h is there. What's b to the x divided by b to the x?
Negative one.
Why
Yeah.
is there not another one there?
Say what?
Why is there not another one there?
Another one where?
Why isn't there another one?
No, another one where? Why isn't there another one where?
The numerator of after you did the greatest common
How many terms are here?
Two.
So there can only be two
Oh.
terms here. Yeah, so this term loses b to the x.
Yeah.
And this term is b to the x divided by b to the x. Yeah. If that wasn't there, you could never multiply back to where you were. Okay. All right. So now this guy, let me see. I'm not going to spend a ton of time. I could put a number here. We can make tables. I'm just going to give this to you. The neat thing about this guy here, and again, if you don't trust me, you could put a number in for b like 7. And you can make a table of values letting h go to 0. You guys with me? And what you'll end up finding is that that is equal to the natural log of b. So just to show you, if I took 7 and I made a table of values for h, and I let h be 0.1, 0.01, are you guys all with me? I would get some numbers out, and what they would be approaching is the natural log of 7.
Okay, so why do you have the B to the X out there?
Because b to the x is here. B to the x is here, and this is the natural log of whatever that base is.
Okay.
Yes?
And it's natural log just because of like math shenanigans?
No, it's because that's what this comes out to be.
Yeah,
So it's easier to explain the other way around, which is kind of nifty. Yes.
You plug in 7 to both b to the x, and then limit plus
No. All this guy is known. He's cool. This is what I'm investigating right now. Yeah. Okay. Yes.
So you're saying the derivative of b to the x is ln of b?
No. What did I get? Tell me everything I just got from doing this limit definition. What did I get?
You got B to the X times the natural log.
Yes. Okay. Cool. Now, is there a certain base that I could plug in that would work really well with this? E. If I made the base E, what's the natural log of E? 1.
1.
So let's really see what this is telling me.
B to the
So
X
in general,
derivative is
if
just
I
B to the
give
X.
you a number to a variable, and I say, what's its derivative? The derivative of it is b to the x ln b. So for example, if I give you 11 to the x, what's the derivative?
11 to the X natural log 11.
Exactly. Okay, I like it. So here's what's really nifty. Here is b to the x, roughly. If you try to sketch the graph of this on top of it, what's true about the slope here?
But it's approaching 0.
Yeah, as I go back,
But
it's
it's
approaching
getting
zero.
really small.
But really small positive, correct?
Yes.
So if I try to graph the picture of the slope, it's really small positive. What's it doing as I move over?
It's doing that.
Getting bigger positive, correct? And then as I keep going, isn't this picture of the slope following the graph? If the base would be E, it would follow it perfectly. In fact, it would lie right on top of it. If the base is anything else, this tells me how far off I am. So let me ask you this. What is G prime at 0 if that's my function? What's G prime at 0? What's 11 to the 0?
1.
Times 11. So I get ln of 11 for the slope, correct? E is the only function that goes through 1 with a slope of 1. So if my function is e to the x, what is its derivative? E to the x, and just to be pedantic, natural log of e, but what's natural log of e? 1. So that what's the h prime at 1? I'm sorry, at 0. H prime is e to the x, correct? H prime is e to the x. So what's h prime at 0?
1.
E to the 0, which is 1. So e is the only base that goes through 1 with a slope of 1. Every other exponential goes through 1 with a slightly different slope. How different? I could tell based on what the base is, natural log of the base. Okay, maybe. Do you all agree with me that 11 to the x should have a bigger slope than 10 to the x?
Yes.
Should have a bigger slope than 9 to the x. So e is the one that goes through 1 with a slope of 1. And what is e roughly? Anybody know?
27.
Good, between 2 and 3. So if I made it 3 to the x, it would have a slightly bigger slope through 1. In fact, how much bigger? It would be natural log of 3 at 1. 4 would have natural log of 4. So as I make the base rise, the slope should kind of get bigger, yes? It's just really nifty that e is the perfect number that it goes through 1 with a slope of 1. That's neat. E is the only function we've seen so far that is its own derivative. So how much are we going to love e? A lot. If you take my 280, I got a little Pokemon comic on my syllabus that says a wild exponential appears. You use derivative. It is ineffective. Anyway, sorry. So that's a dumb joke for some of you guys. Okay. So help me out. If I gave you 3.9 to the x, what is the derivative of that?
3.9 to the x times natural log 3.9.
Yes, it doesn't matter what the base is. Now, obviously the base can't be 0. That doesn't make sense in the first place. Base can't be negative because poor little natural log is going to freak out, right? So it's got to live within the boundaries of this function. Okay. Okay. Why would this equation not make sense?
Can't have the natural log of the base.
Well, not even thinking about derivative.
You can't.
What could
have
x be?
Any number.
So could x be 1/2?
Yeah.
And what's a 1/2 power?
A root.
And is this real?
No.
Okay, so it's like, but what's right next to 1/2? It's okay, but then what's right next to that? I mean, so it would be undefined at infinitely many points that are really close to it. You don't want that. And again, that's a side note. It's just, so whatever the base is, it's got to live within the confines of what natural log requires. Okay. So what do we know so far? If I gave you a function like this, can you guys tell me the derivative of that? Do it by just don't say anything. Take a second and take the derivative. Yeah, that's right. It's in this section. Yeah, good. I need to start doing this more often. You remember I could write it like this also? Right, there's another version of the notation for G prime. Now who's got this? The 7 comes down, whatever's there already multiplies.
And 6.
4 thirds.
Good, that comes down.
2.
Have I told you the shortcut yet where if you're taking a derivative, you just go top minus bottom over bottom?
Yeah.
1 minus 3 is negative 2 over 3. Done. If you're ever taking a derivative of something with a fractional power, just take top minus bottom, but back over the bottom. I think I showed you last time why that's true. Okay. So 1 minus 3 is negative 2, back over the bottom. Done. Okay. Just to save some of you taking calculus, no plus C's yet. We're not to integration yet. Okay. So what about this one? What you got, Jeff? I don't know, man. X to the 141 over 138 minus 7 to the x. You say chain? No.
We're not gonna get into it.
Well, we are going to, but we don't know
But
yet.
like, this is leading into.
So what I try to say in each of my math levels that I teach is that I have a process that does not care what's there. So the process for x to any number is the same, no matter what. Just the thing that's in the power could get gross. But the process doesn't change, thank the gods. So what's the process for x to a power?
Down.
The power comes down. What's 141 minus 138?
Negative 141 over 138.
No, what's 141 minus 138? 3. So 3 over 138. And again, real quick, if I subtract 1 from this, don't I have to multiply 1 by 138 on top and bottom? Wouldn't I then be subtracting 141 minus 138? So why do that? Just do it right here. That's why the shortcut works. What about this guy?
Natural one.
Yeah. What did I just figure out? What does this tell me?
Derivative.
Good, it's the derivative. It tells me the slope of this function at any input that it can use. Yeah. Okay. Yeah, so we only know those two things so far. The power rule, and now we know for any exponential functions. Okay. Make sure you guys figure that out. So, we're going to investigate what happens if I have the product. This is 3.2. The product and the quotient. So let's start with the product. Product of two functions. So if I just give you one function, the derivative tells me how quickly that function is changing as I move along the x-axis, right? That's the derivative, that's the slope. The rate of change of the function, yes? If I have two functions that are multiplying together, then each of their rates of change are going to come into play. Does that make sense? Not really like this, but sort of like this, a gear inside of another gear. If I make the gear inside move and the outside gear move, then together they're going to tell me a total movement rate. Okay. So I want to start off with just the idea of what the product rule cannot be. So I'm going to write a function in a really strange way. Okay. What is that function? X freaking squared. But let me just, isn't it true that x squared is x times x?
Yes.
So if I develop a rule for the product of two functions and I apply it to this, it better give me the same damn answer as I get for x squared. Because that's the same damn function, you guys agree? So let's investigate this. One idea you could have is that maybe the product rule is a cool, chill dude. It's not. And maybe I could just take the derivative of each thing and multiply them together. Well, what's the derivative? If I think that's true, what's the derivative of this? No, what's the derivative of this? 1. What's the derivative of this? 1. So if I think that's true, the answer should be 1. Is that the derivative of x squared? No, so that's bullshit. Yeah, that cannot be true. So I cannot take the derivative of each piece of a product and multiply them together. We know I can't. That's an immediate counterexample to that idea. Are you guys understanding what I'm saying? If that worked, I should have gotten 2x, because that's the derivative of x squared, right? Okay, good. So, with that in mind, now you understand better why I'm about to do what I'm about to do. What's the only thing we have to investigate what the derivative of something is at the
The
moment?
limit definition.
That's not something we have memorized or shortcut for. Limit definition. So we are going to investigate a function that is actually the product of two functions, yes? I can't remember the book that does that. We're going to go through the derivation. You're never going to have to go through the derivation yourself. We're going to derive it. You're going to see why it is what it is, and then you're going to memorize the rule directly. You're not going to have to do limit definition. You with me? I might make it a bonus question at worst on the test. So let me see if you guys really get this. If I want to figure out what h prime is, h kind of sucks, but too bad. What is h? Don't I need h of x plus h? Let me change this to k. Make that a k, so I don't have all the h's running. If I want to figure out what k prime is, don't I need to know the limit of kx plus h? Right? Okay, let me just write this down. That is how I figure out k prime, yes? What is k though? What is k of x?
F of x times
Yeah,
g of x.
f of x times g of x. So what is k of x plus h?
F of x plus
Good,
h.
f of x plus h
Of x. Oh.
times g of x plus h. Okay. Stop for a minute. This is one of the, okay. It's one of the coolest things ever, but it's something you would never think to do unless you've done so much math that you know this makes sense to do. There's a lot of places in math that we do what I'm about to do. Can you see a damn thing you can do with that, by the way? Does anything do anything? And you're all like, dude, we don't even know what F and G are with this shit. I don't know. So I'm going to do something out of nowhere that I don't blame you if you would never think to do this in a million years. You're fine. Because you're not used to playing with shit like this. So here's what I'm going to do. I'm going to add and subtract something.
Okay.
Does everybody agree that if I add 7 and subtract 7, I didn't do anything?
Yeah.
So I'm allowed to do that, right? I'm not going to do 7. 7 won't help me. So as I write this down, I'm going to try to remember what it was I wanted to do. Oh yeah. I'm going to add and subtract this expression here. I'm going to try to fit it. Okay, let me zoom in on that. So I took this and this, and I added, subtracted fx g of x plus h.
Okay.
Again, would any of you think to do this in a million years? No. Of course not. I don't. Why would you? Yes.
In the middle, when we did minus f of x, g of x plus h.
Yes.
Is it supposed to be just f of x, g of x?
No.
G of x?
Nope.
Where the h?
Which h? I need you guys to understand. Could I have put minus 7 plus 7?
Yes.
Could I have put minus Jeff plus Jeff?
Yeah.
Could I have put minus French plus French? I can put minus whatever the shit plus whatever the shit. Any damn thing I want to. So when you say where the h came from, wherever the hell I want it. Now, I know what I want this to do. I didn't ever play with this directly by myself. I was shown this a billion years ago, and then I kind of remember when I have to teach this. I have to go, oh yeah, that's what you do. But this kind of thing happens a lot. In fact, we do that with, we sort of do this with the how to factor when you have like a number out front that's not a 1. Don't we add and subtract stuff in the middle that becomes the middle term that was there? We sort of, where'd the 3 come from? No, we can just make it whatever we want. That's going to work. So, okay, watch what happens next. So let me rewrite this because I got it kind of smushed up. So what was there from the beginning was this. This was here. And then I subtracted this and I added the same thing. So I actually just did nothing at all. Way to go, Jeff. Okay. And again, do not be concerned that suddenly you're going to have to do stuff like this out of nowhere. No, stop it. So now watch what I can do. Do you see what comes out of these two?
G of x plus h.
G of x plus h. And what am I left with?
F of x plus h minus f of x.
Does this look familiar?
Yeah.
All right, let's keep going. What comes out of these two?
F of x.
F of x. And then what do I have left?
G of x plus h minus g of x over h.
There we go, look at that. That's my kind of problem where you gotta turn the paper.
Ugh.
I had problems where I taped paper next to other paper. So, until you've done that, you can't go here.
Is that in grad school?
Yes. All right, again, getting past the minus plus thing. Somebody had all the time in the world. Back in the day when they had no freaking PlayStation, they had the phones, they had candles. What do? You just play with math. And somebody's like, holy shit! You know, so he just had a million years to play with. Not a million, but you get what I mean. So of course he's gonna eventually come up, oh, look at that. We wouldn't do that, we don't have that much time. Are you kidding me? We have too many distractions. So dealing with the minus plus thing, does everybody see the algebra I did? All I did was I took a g of x plus h out of the first two, and I took a f of x out of the second two. That's all I've done. And look what I'm left with. Two expressions that we know what they represent. So if I do the limit as h goes to 0, well, help me out. What's the limit as h goes to 0 of this? Let h go to 0. What do you get? G of x. Right? Let h go to 0. You get g of x plus 0 is g of x. And what's the limit as h goes to 0 of this? No, come on.
F of x.
No.
Oh, of that.
0 over h.
F of
No,
x.
come on, guys. Come on. This is
F
the
of x.
definition of what?
Of the
Yes,
derivative.
it's f prime. Oh my God. So this limit of this, that is the definition of f prime. And what do I have over here? F of x.
You get f of x.
And what's this guy?
And
G
g
prime.
prime.
G prime thing. Somebody's like, let me get ahead of this for this guy. So what does this mean? This means when I am given a product of two things. And don't worry, we're gonna do a concrete freaking example. Don't worry. Because I know you're all like, yeah, I would be too. Can you do a concrete example? When I'm given the product of two functions, watch this, it's kind of nifty. They each get a term. I'm gonna reorder this a little bit. F prime gets a term, g of x is just sitting there, plus f sits there and g prime gets a term. So in just about every derivative rule we're going to learn, at the heart of each of them, each piece gets its own term. Do you guys see how each piece gets its own term? F gets a turn taking the derivative, g has to wait. Then g gets its turn, F is sitting there, yes? Okay, one of my favorite sounds.
It's kind of like with the whole cosine and sine thing about
We'll get there.
cosine from
So coming back, have we developed a process for the product of two functions, checking the derivative? We have. So let's go back to where we started earlier. So I've got this function. I know it's x squared. Let's pretend like we forgot that x times x is x squared. That means you have some trouble, but let's try it. How would I do the derivative of this? What's the rule say? The first guy gets a turn, second guy's sitting there, right? Plus, the first guy sitting there, second guy gets a turn. That is the rule. So I highly recommend you don't do any derivatives on the first step. You just write what the rule says. Now I worry about the derivatives. So I'm not trying to do too much in my head at once. What's the derivative of x?
1.
Holy shit. What's the derivative of x?
1.
Holy shit. And what's x plus x? Holy shit. So, is the derivative of x squared 2x?
Yes.
Somebody was
Yes.
shaking their head. I am. Okay.
Yes.
Somebody shaking their head. No, I was like, I was going to fall out. So the derivative of x squared is 2x. Now listen. We did not develop this process to do frickin' x squared. I really want you to understand. That's crap. But this is a great check. Anytime I make a new process, it better work with stuff we already know. Does it? Yes. So, let me ask you this. Here we go. Can you guys take the derivative of this? Try it. Go for it. Do I have enough? Yeah. Oh, I gotta do that. Yeah. So this is going to seem like a silly question. How many functions are involved in this product? 2. Good. So I'll show you an example where the product will, you could have a bunch of functions being multiplied. Just kind of extend the rule. So I'll show you that example. So what's the rule say to do?
It says x,
First dude gets a turn, the second guy's just sitting there watching, right?
and then e the x.
First dude sitting there watching, second guy gets a turn, yes? What's the derivative of x squared? What's the derivative of e to the x? Oh, you're cool, e to the x. You guys all with me so far? What's that? Is this x squared times e to the x?
It's the e to the x, I guess.
So e to the x, its derivative is just e to the x.
Yeah. Here, let's do this. I want everybody to buy into e to the x. Let me see, is that what I need to make sure? Yes. E to the h, there we go. All right, just go with me for a second. Shoot, I did not bring calculators. Can you guys help me out there? And you, oh, cool, okay. You're closer than mine. Thank you, Mike. We both have the same color, like it.
I know, right?
All right, so here's what I'm gonna do. What input should I do? Some of us still have trouble with this. I want my inputs to get close to 0. I still have people doing 1, 2, 3. Doesn't make any sense.
0.1.
Yeah, I want to get close to 0. I can also do negative 0.001, negative 0.01, negative 0.1. I like to do it that way so I can kind of do this when I look for a pattern. All right, so what I'm going to do is I'm going to put in here, I know this is h, doesn't matter what variable, so I'm going to do e to the x minus 1 divided by x. Then I'm going to go to table. Let me do this. This makes it easier. Sorry, I'm doing a lot of weird shit. It's just a quick way to clear my table. Okay. I really hope you didn't need that stuff, Mike. You gave me a kind person. So now I can put in here 0.1, 0.01, 0.001, negative 0.001, negative 0.01, negative 0.01. Okay. So let's zoom in on this. What is that approaching? 1. There you go. If I put, let me see. Is everybody cool with that? You guys see that?
Mhm.
So since I need you to remember this weird shit? This is what we did, this is what we got. This piece of it is what we weren't sure. So if I put an E here, we now know that this goes to 1. You guys with me? That shows me that if I make this E, it is its own derivative. E to the x times 1, it's its own derivative. Now, let me see, real quick. If I change this to be 7, like I was saying earlier, how did you become a times x? What did you do? Okay. And I go back to my table. What's it look like that's approaching?
2.
No, not 2.
1.94.
1.95, 1.9 something, you guys with me?
1.5, yeah.
Let's go even closer just to get a better feel for this. 0.00001. Yeah, 1.9459. Now, what did I claim? If it's 7, what did I claim it should be equal to? The natural log of 7, yes?
Mhm.
So let's see, what's the natural log of 7? Holy shit. Natural log of 7. Oh, Jeff and a half. Natural log of 7. Does that look familiar?
Yep. Okay.
Okay. So that limit that we set up, it is equal to the natural log of the base that was there, which leads to E being its own derivative, because then that piece would be 1. I showed you that's the first thing we did. Okay. Is that better? I mean, that's what I meant. You could set up a table. Okay. So now I know I can memorize the same way you guys have memorized what is the derivative of x to the n.
And
And x
to
to the
n
n
x
minus 1.
to the n minus 1.
Now you can memorize that e to the x, its derivative is
To the x.
e to the x. Thank you, e to the x. You're the real.
And that's the exponential derivative.
Yes, that's the exponential function. That's the exponential. Yes. Okay.
And then the other one with the whole bx to
Yeah, that's the general. So
times.
like, if I have e to the x, what's its derivative?
That's b to
Still
the x
itself, but there's a little adjustment.
times the natural log of e.
Yeah.
So that one is exponential derivative.
And
other
exponential.
One, the
Yeah.
other one is
The exponential. Yes.
the okay.
Kind of sucks that we use the same word for both, but. So this is the general rule. This is a specific circumstance. If b is e, natural log of e is 1. That's beautiful. Okay. So we're expanding the number of functions whose derivatives we know. So what about, okay, product rule by itself is a little weak until I give us some more functions. Yes, sorry.
Did you show us what the derivative was supposed to be for the x squared dx?
Oh, did I? Did I not do that?
So, so this new one is the product rule.
So here, let's do it again. X squared e to the x, the derivative would be
2x.
x squared prime e to the x plus x squared e to the x prime. 2x e to the x. Yeah, we did this, right?
I got to that part. And
Yeah,
then
I mean, that's it.
that's it.
And that's product rule.
That's product rule. So when I have a product of two functions, this is the rule that I use. I like it. What do you think the rule that we're going to do next would be?
Quotient.
No way. So now we're going to talk about what if I have two functions that are divided, right? By the way, I'm going to try to let us out a little early today also. So are you guys cool with just moving forward? I'm going to move our break to the end. So add it on. Don't get too excited. I'm not letting us out at 5. Yes.
What time?
I
Can't
don't know,
ruin
last
the
time,
Can't ruin the
35
surprise.
or something, we'll see. How about
Last time-
worksheet stuff? You're good, if you got it,
Yeah.
okay. If you see a product of two functions, and I'm asking you to take the derivative, then you use product. So watch this, I promised you I'd show you this. Do I have enough functions for this? No. We don't know enough functions yet. Screw it. Alright, I don't have enough. So, like, I was gonna do this, and then I was gonna have one more function here. We don't know the derivative of any of the function yet. I was gonna put sine here, but we don't know the derivative of sine yet.
yes, we do.
We do?
Yeah.
Oh, we did.
Last,
Okay. So
Last
who remembers the derivative of sine?
cosine.
Oh, sorry.
Good, I like it. Thank you, sir. So how many functions are involved in this product?
3.
3. The great thing about product rule is, so I got like f times g times h. So the product rule just says each one gets a term. So f prime gh plus fg prime h plus fgh prime. So each one gets a term. So it just extends. That kicks so much ass. Okay. So I'm not going to give you a string of like 80 functions. Don't freak out. So how would I do this derivative?
It would be
So the x squared prime, and these guys are just sitting there
dx
waiting.
Sine x, and then plus x squared dx prime sine x, and then x squared e to the x, and then sine x prime.
Oh wait, see, so product rule is kind of cool, and you just have to remember, for every rule we learn, you never take the derivative of everything all at once, ever. Each thing gets its own term. Every rule we learn is going to have that as a central part of it. So now you just do all the derivatives you highlighted for yourself. So qx, derivative e to the x,
E to the x.
and derivative sine.
Cos.
Okay. Yes. Okay. I didn't prove this, but did I tell you what the derivative of cosine is? I think I did.
Negative sine.
Negative sine.
Sine.
You didn't prove it.
Didn't prove
You
it.
did tell us. So.
So a little hand waving thing. Here's cosine, right?
Yep.
What's the derivative right there?
0.
Good, because it's a slope, right? What's true about the slope here?
It's getting negative,
No, not getting negative.
or it
It is negative, correct?
is negative. Yeah.
And then right here, do you
Getting
agree that's the
bigger.
most negative right there? Because then what's it do after that? It starts to
It starts to climb
turn,
back
yes?
up.
So it's going to be negative until about right here is the most negative, and then it starts to turn, and then right here, 0 again, right?
Yep.
And then it's just going to keep doing that because cosine just keeps doing the same thing like a crazy person.
Mhm.
What is this the graph of? Is this a graph of sine?
No,
It's the graph of
it's the graph of negative sine.
negative sine. It just flipped sine.
Because sine goes up first.
Yes.
Not down.
So the derivative of cosine is negative sine. We're going to learn today that the derivative of all the stuff is negative. That's awesome. And there's also an analogy, and you'll see, we'll do it. It's not going to be as hard to memorize the trig derivatives as you might think if you've never seen them before. And by the way, you need to memorize. In fact, you're going to memorize every derivative we do, basically. I'll tell you, there's anything you don't have to memorize. So let me ask you this. How would we... Well, this could be useful. How would I investigate tangent? No. Now what is the answer? How would we get to the answer?
Oh, the stupid
Do I know sine and cosine derivatives?
Yeah.
Alright, so what's tangent in terms of sine and cosine?
Sine over cosine.
Sine over cosine.
And I have made two functions that are dividing now, right?
Mhm.
So we gotta take a little side step. We gotta figure out what the quotient rule is. If I know what the quotient rule is, I can figure out what the derivative of tangent is, because tangent is just the quotient of two things I know. So I need you to start realizing, we're learning new rules for different functions. When I combine those functions, I could get other functions. If I knew rules for product, quotients, I could then make rules for these other functions that they combine to become. I don't have to keep doing limit definition. What is the last thing you want to do to figure out the derivative of something? Limit definition. As much as I love math, I don't want to do that all the day, right? I want to build off of shortcuts we notice. So we're going to learn rules for functions like we did with b to the x. And we're going to learn like general rule, like product rule is not a rule for a function, it's just a rule for any freaking product of two functions. Then I can start freaking making all these different derivatives of all this different stuff. So, how do you think I'm going to investigate the quotient rule? That's crazy. I'm going to make q of x is equal to f of x over g of x. If you don't want to write this, I understand. It's basically going to look a lot like what the last one. You all understand this is going to be a little worse because there's a frickin' fraction, yes? But it's going to look very similar to what we did before. So if I want to know what q prime is, let me see if I can truncate this a little bit. I got to do q of x plus h, which would be f of x plus h over g of x plus h, minus q of x all over h. Is that cool? So q of x plus h minus q of x divided by h.
Okay.
What do you think the first thing I need to do is, besides go running and screaming? Yeah, come on.
Yeah, so
So I multiply the first guy by g of x, and the second guy by g of x plus h. And on the bottom, I'm just gonna get g of x times g of x plus h. Is that cool? Exactly. And then this little h dude, just make it a part of what you know. Just joins everybody else. It's also dividing, so it's like, hey guys, I've been down here for a while. Does the top look sort of similar to something? So what do you think I'm gonna do?
You're gonna add this.
I'm gonna add
thing.
something because I'm a creative little math guy. Okay. Sorry. But what I'm gonna add and subtract is a little different. I wrote it down somewhere, so let me see if I remember. So it's gonna be. Yes, that's what it is. Minus f of x, g of x, plus f of x, g of x, minus f of x, g of x plus h. All over h, g of x, g of x plus h. Oh my god! So don't blame me if you stop writing. You're fine. You don't have to write all this down. There's no real point to it. So consider not writing this down. Okay. So just to kind of jump to the chase a little bit, let me see if you guys see this happening. So I can factor g of x out, yes? And I'm going to be left with, and this is going to be over and then I'm going to get f of x plus, oops, I left the h over there. F of x plus h minus f of x over, yeah, over g, h. And this piece, of course, is my f prime, yes? Okay. Now, can anyone see ahead of what's going to happen here? Aren't these in the wrong order? Aren't you going to take an f out, but isn't the g of x plus h supposed to be first?
Yeah.
So this will be minus f of x, so that I can make my g of x plus h first. Then my g of x is next, over h. Good lord. Oh, I see what I did. Let me see if you guys will forgive me for this. That should be in here. Oh. So let me just cut to the chase. This becomes f prime, yes? F prime g minus f g prime. And I'm letting h go to 0, so yeah, I get g squared on the bottom. Okay, maybe. So look at the difference. What was product rule? If I just cover the g squared, what's product rule? What's different?
It's a minus sign.
Instead of a
The
plus.
signs are different.
Remind me, which function was on the bottom from the beginning?
G,
If I brought it up, what power would it have?
a
Negative
power.
1. So if I take it through, wouldn't a negative come down? I really want you guys to understand. So of course the part where I took the derivative of the function that was on the bottom should be negative. Because if I brought it up, it would have a negative 1 power. And the negative would come down, yes? So there's a whole little song. Heidi Low and blah, blah, blah.
Oh, yeah.
All right, here's my song. You ready? This is my song. You ready? Here's my song. It's very long. Get ready. Top first. That's my song. So when I have a ratio of two functions, how do I take the derivative? I do the derivative of the top first, and then everything else flows. The top looks like product rule. You got to remember it's over g squared, right? So if you like the little song, you can ask a tutor for it. Loading high, low, blah, blah, blah. Sorry. I want us to remember things like the part where I take the derivative of the function that was on the bottom is negative. Of course it is. That makes nothing but sense because it would have a negative 1 power on it. So of course it's going to be negative. I don't need a song to help me remember that. I just see why it makes sense. I'm not against songs, but I don't want to make it seem as if, oh, you can't possibly survive this without knowing the song. And like, of course you can. Okay. So let's do an example, and then we'll hit tangent. Let's do an example of something that's not trig. Alright. Now just to point out to you, you could do long division. Does anyone want to?
No.
Okay, so let's attack this thing. What does the rule say? What's my song? Let's see if anybody likes my song. No, that's what's top
Top
first. You gotta hit that right key. Top. Okay.
Top first.
So I'm gonna do the top derivative times the bottom. Minus, of course, because now I'm gonna take the derivative of the bottom all over bottom squared. So it's basically product rule, except that's a minus and divided by this thing squared. When we learn chain rule, I will come back and show you. Young Jeff, when I was learning calculus, I never did quotient rule. I have come to appreciate it now. But when I was first learning this stuff, I always brought this up and used something we'll learn later called chain rule. Yes?
I don't know if it would be important, but you had the plus 1 over there.
Oh, I see, yeah, thanks, man.
Extra plus one? Oh,
Is
okay.
that important or?
So this
It's
is-
very important, thank you for that.
Yeah.
Well, to be honest, it wouldn't have changed anything, but, okay.
Yeah.
What's the derivative of x squared minus 1? 2x. And then this is still here. What's the derivative of x plus 5? That kicks ass. Now, can anyone see what the biggest mistake is on this problem? Some of you guys might be like, no, I see what to do next, but that's the mistake. What looks like it wants to cancel? The x plus 5s, yes?
Yeah,
Why can't I just do that?
because it's attached to the 2x.
It's a minus. I can't, division's not the opposite of minus. I can't break into a subtraction problem. Yeah.
How come that says x squared minus 5?
I don't know, because I'm having a day. So I can't kill the x plus 5s. Because what's being divided by x plus 5 squared? Both pieces up top, yes? So what should I do up top instead? Distribute. I don't know, this might look familiar to some of you guys who are in a different class with me. I don't know. So you get
2x plus x minus x squared plus 1.
so you can ask So then I get x squared plus 10x minus 1. And you do have to check to see if it'll factor, but that won't factor, right? So that's the derivative. So again, if I plug a number into this, it will tell me the slope of this function at that x value, right? If I plug an x value into this, it still does the same thing. It tells me the slope of the original function at that point. When I take a derivative, the processes we use to do it will change, but the meaning of it will never change. Yes, I don't know. I'm really not. It's a weird day for me. Yeah.
How did you get the top answer? X squared plus 10x.
How do
Are you cool with this
still
one?
Yeah.
Yeah.
So then 2x squared minus x squared
Oh, okay. So
is x squared, and then a 10x plus 1, yeah. Just
Oh.
put like terms together.
Got it.
Yeah.
Is that a limit question?
Sort of. So what's the base, what's the way to get derivatives is limit definition. Did we use the limit definition anywhere? We used a process we built from limit definition. So yeah, the process is built on it, but we don't have to directly look at that shit. Okay. So coming back to tangent. If I want to know what the derivative of a tangent is, and I have no idea, I could do limit definition and plug tangent in. My God, we don't want to do that shit. Tangent of x plus h, no. So instead I'm gonna write it in terms of stuff I already know, like we did a second
Then
ago.
you use the quotient.
Yeah. So you start to see the more functions we build a derivative rule for, the more I can combine them, make other functions that I can then discover the derivative rule for them. So it just sort of becomes this snowball effect. The more I learn, the more I can continue to learn. The more I learn, the more the snowball gets huge, and then I'm able to do everything in the universe. Not by count one, sorry. So how do I set up this guy's? Take a minute, try to figure out. Set up this guy's derivative. Sine x over cosine x. So use the quotient rule. Do it yourself. Don't say anything. You got it. Oh. While you guys are doing that, sure. Hey. Regular. Stuff that I've created recently and that people don't get back yet. Joseph. Robert. Oh, you're the other Joseph. You're like Joseph Kazia. Robert, did you get my email?
Oh, no, I don't. Is there any email?
It was about your documentation and stuff, so
Oh, okay.
I got it back. I was just saying, just check you.
Oh, okay, sorry.
You're good. Oh, sure. Oh, you're. This is Mateen. Dylan. Teresa. Mike is sort of here. It's like a little angel. Ryder. Yeah. Gary. All right, guys, let me catch up here. So how's this get set up?
The derivative of sine
Good. The top
times
first.
cosine minus the derivative of cosine times sine. Or, yeah, I mean cosine squared.
Okay, good. I like it. So f prime g minus g prime f all over g squared. Okay. So now I can focus my attention on the derivative pieces I need to do. So what's the derivative of sine? Cosine. And what's cosine times cosine?
Cosine squared.
Crazy. Derivative of cosine? Negative sine, good.
So negative sine, whoa.
Negative sine times negative is positive sine. Right?
Got it.
If that's negative, that becomes positive. And of course, what is cosine squared plus sine squared?
1.
And what is 1 over cosine squared?
Secant squared?
Yes. S goes to
Oh.
C, C goes to S. Secant is 1 over cosine, cosecant is 1 over sine. This is interesting. Here's another one you have to memorize. The derivative of tangent is secant squared. Is that an obvious thing? Shit, no, right?
But you could build.
That is not, you're like, of course it is, Jeff. I do that, yeah.
But you could build to it.
You could graph tangent and sort of see how it matches the graph of secant.
Or you could
Squared.
do what you just did, using like like always fall back to
You can always use the quotient
like
rule.
what you just did,
We're good. Yeah, we got it.
But like, if you forget,
Yeah, I guess.
Oh, if you forget, you gotta redo all this stuff. But I highly recommend just memorizing. Now, let me ask you this. If you had to take a guess, what do you think the derivative of cotangent would be?
negative.
Good. Somebody remember. Negative
Negative.
cosecant squared. How do we prove it? Well, cotangent is
The rec-
cosine over sine, yes? What we just do, everything we just did?
Yep.
Okay, nothing. So now we know the derivative of cotangent is negative cosecant squared. So the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. All the co stuff comes out negative. So since trigonometry, you might have been wondering, why the hell did I not just call 1 over sine cosine? Why? Well, now you're starting to realize there's other relationships. So what are the only two things we don't know the derivative of yet? Cosecant and secant. Let's do secant first. Who has a plan or can think of a way that we can investigate what the derivative of secant is? Not limit definition, dear God.
Well,
Can I rewrite it in terms of
secant-
something we know?
Secant is 1 over cosine.
1 over cosine. And let me just say this. You have to be careful.
1 over negative.
That is not secant times x, yes? That is secant of x. So, yes, those would be 1 over cosine, yes? And then I could use quotient rule, yes. Quotient rule says what? What gets me started? Top first? Right? So the top gets a turn first, the other guy waits, minus, the top waits, the other guy gets a turn. All over.
Cosine squared.
Strong on the course. Cosine squared. I like it. What is the, now here's what things get into, what is the derivative of 1?
0.
Good. So this whole term is 0. Good. What's the derivative of cosine?
Sine.
Negative sign. So negative sign is sine. Now, let me stop for a minute. You guys semi with me?
Yeah, but
1 prime is 0. 0 times cosine is 0. Derivative of cosine is negative sign. Negative sign is sine. One prime is 0. It's got a 0 slope. That's 0. Cosine derivative is, and negative sign is positive. Over cosine. Ah,
What about the first cosine?
okay. What's the derivative of 1?
Oh, 0.
Times cosine is 0. So whenever you take the derivative of a constant, whatever else is multiplying by it goes to 0. Yes? 0 times anything just gobbles it up. Can I rewrite this? If only that was a first power, then what would this be? Yeah, so can't I do this?
Tangent times whatever cosine.
What is sine over cosine? Tangent of x. And what's 1 over cosine?
secant.
Secant x. So let me write it the way that I know it. The way that I know it is the derivative of secant is secant tangent. That I think is probably the worst derivative rule for trig, right? So who's got a guess as to what the derivative of cosecant is? Negative.
Negative cosecant.
Cosecant.
Cotangent.
Cotangent, kick ass. So to memorize the trig derivatives, you only have to memorize 3 of them because the other 3 are the co with negatives. Does that make sense? You can cut your memorization in half. So the derivative of cosecant is negative cosecant cotangent. Alright. So, last thing. I told you I'm going to let you out early, but this last thing, let's see how long it takes us.
So one over cosine, that was secant, right? Tan secant.
I'm sorry.
Tan secant? Tan.
Tangent secant, yeah. 1 over cosine. So we're going to look at the side that says differentiation practice. Don't worry about the side that says 3, 4. We're not there yet. Yes.
Yeah, if you look on the back,
Yeah.
there's section 3, 4. It's chain.
There's a chain.
Gosh, boy.
Just gotta remember.
Chain rule.
Just gotta remember the last part. That's all.
I
Just gotta always remember.
despised chain rule.
You gotta always remember the last part. That's what I remember. You gotta always remember the last part. That's always the part I
Oh,
missed
yeah.
it. Oh, the end is always the part I missed.
Oh, I see.
Yeah.
I go
I
through the whole
remember-
chain rule, but I forget to.
I remember
I want you to focus on
what my
this.
friend did was outside derivative times inside
Yeah.
times out times inside.
So let me ask you a question that will help out on 2 of these problems.
Sorry.
What is the derivative of any constant?
0.
Zero.
Okay. So let's try the first 3, right? Go ahead and do the first 3. If you're near people you want to work with, feel free to do so. If you don't trust any of these people, then that's fine.
You're gonna rewrite the, like if it's like a
So
square, a root, rewrite it as a fraction.
Yeah, the rule requires x to a power. So it's not like a choice we make, we have to.
Yeah.
So it falls into the rule.
Honest rewrite.
try the first three. You guys are just hearing. Try the first three. Just to make sure everybody's on the right track. For part A, are you going to do the derivative immediately?
No,
Why not?
because you have to get that, one, you have to get the root to a
You
power.
need everything in the
and
form
two, you have to get the last one.
x to a power, right? So first rewrite it, don't do a derivative yet. The last one. So, if I change first over this, I'm gonna get a part. That's cubes right now. So force it up. So 3x to the negative. It's a negative power, that's gonna split. X to the negative. Because those three x's want to be on top. Yeah, that minus sign is just there.
Do you just bring the fraction like straight down here? So be the
Yeah.
3/5 times 2.
Powers on the top.
Yeah.
Okay, so this is
Because any whole number
yeah.
is the number divided by one.
Oh yeah, yeah. And then 3/5 minus 5/5. That's 2/5.
But like, yep.
Sometimes I like.
Yeah. So
Yes.
power on the top.
Is
two to
that
the bottom.
starting to what sort?
Exactly. You couldn't take it.
It's not gonna be negative. That's the only, it's not, it's, the powers are gonna be negative. Because, so. Oh, wait. No, it didn't.
Root on the bottom, and then this should be.
So I was rewriting this.
Flip down.
Okay, yeah, okay, so this
That
is
should be
going
raised to negative.
to,
That's
because
because
it's
they're
not
telling you we don't like it
on
up here. We'd rather be on the bottom. So they're all negative.
Like this root, if this root isn't in the denominator, so
Cosine
that's
of
all,
two is constant?
that this is positive. That the rest is fine.
But wait a minute, it's only a percentage.
If, okay, so let's say, let's say instead of
If I did 3 times, you're. So don't even think of it as a
like over
It just comes to one. So it's 3 times.
Okay.
let's just say for instance, like for example, it was this, it was that, right? So then,
Yeah.
Alright,
the derivative
roots on the bottom like plants.
of that
Powers on the top. And then negative power.
of this,
So I like to keep it
going
as
up,
positive,
so that
but push
means
it up.
power.
Negative.
Because when you bring it up, this becomes so 2, and then bring this around, right? Right? You take a root, this ends up on the bottom.
Right.
2 x. So negative, or just getting rid of the
If I divide somehow.
So this is the only one.
The only way I can change the coefficient is subtracting it.
No.
No.
So I had.
That would be hard, because it's not because the original one is the denominator.
Where I got that negative there,
Uh-huh.
is
That was the only part that wasn't right.
what I did
Yeah,
is I
you take it through
took
it, yeah, just pump it down,
the,
good, multiply by whatever's there already.
So what, would it be like?
and I put it over the 5.
Yes, because what I always remember is that like, okay, so right now, the is a power.
Right.
So this is right now, power. But the drip on top of better, right? And then, so that applies to the bottom.
Oh, okay, so what I had done
What you had done was
is I
correct,
taken
except for the fact that
the
it was
3
negative.
minus 5,
Yes.
and that only is the denominator.
If
Yeah, you
the
bring it up.
only time that the exponent
derivative says whatever the hell
for
this
that
is.
is negative is instead of the original word. That's fine, yes.
Yeah, totally. Yeah, but look back at heartbeat. So why is there a 0? It's not very dependent, these are all constants.
Okay.
What is cosine 2? It's a constant, so it's derivative should be. Yeah.
When you want something across the line. But to do that, we have to switch signs. So this is a positive right now.
Yes.
Bring it across.
Cosine by itself.
So this
So only by right. If I just say, do that, what would you say? Yeah, square root of 1, right? So you just write cosine, it doesn't equal 1. So this is cosine of 2 square root of 1. What is cosine of 2? Is it a function, number? If you plug that in your calculator, you get a number. You don't have to. Don't do it. Would you? What's cosine of 2? Is it dependent on the
So now, thinking about
It's just a number. So what's its derivative?
right? Because you just fixed that power. So you bring this
So
down,
that
right?
would be 6 over 5.
What would its power?
Again.
Remember, you're subtracting 1. So if you want to, what I do sometimes is I make 1 into
And if you break these up, because
So if you
it's
take
over 1 and 2.
minus
1 minute.
5 minutes, right? So it's 3 minus 1.
If you break these up, then one of these would still be 2 of that. I think that's what it's like. Squared. So 1 2x plus 3 cancels. You still have another one down the side, but you don't have to break them. You're short of. You should really multiply through and put your like terms together.
So it would be a positive, so 2 is 20.
So it is negative sign around,
Right?
Kind of, the only rule is really you multiply it's gotta be in parentheses. If you're in the top line, it should be in parentheses. 2x plus 3.
it's cosine of 2, not like cosine of 2 times 2. And you put it in and then calculate
Yeah, what's
Put this whole thing together.
What's the slope?
Now it's not really a function, it's a number.
Alright guys, let me catch up. What's this one?
Yeah.
Freaking 0, because cosine of 2 has no variable dependence, it's a constant. So its derivative is 0. This guy, when you go to rewrite this, you have to remember roots on the bottom like plants, powers on the top because they're powerful. And this one, oh, what's up? Sorry.
You have to do the, don't you have to do the product rule for B?
Alright. You ready?
Yeah.
If I ask you can you simplify this for me? Simplify that. What would you say?
And
That's
there's nothing in
freaking me
it.
the shit out.
It would be
What should
Whatever.
you say?
I need more information.
Yeah. What more information do you need?
Yeah, I know.
we need something
The
under the
square
root.
root of what, Jeff? right? You're like, are you feeling okay, Jeff? Did you take your meds this morning, Jeff? You need something to drink. That makes sense now. Square root of squiggle. 9. Yeah?
Squiggle to the one.
So, cosine, if you see this, that does not mean anything. It means just as much as this. So this is not cosine times 2. Because cosine by itself doesn't mean anything. It's got to be of something. So what is this? Cosine of 2. If you did, do not do this. You could, I don't care, you could. If you plug it in your calculator, will you not get a number out?
Yeah, you'll get a
Yeah,
constant
so
number.
as x changes, does cosine of 2 care?
No.
So it's a constant, so its derivative is 0. I like it. This is not cosine times 2. So let me ask you this question, because we're going to see this kind of thing later this semester. What is the difference between these two things? Let me see, I don't know if you can see them. Yeah. Is there a difference between these two things? What's the difference? What's the top one? Cosine of, so tangent is inside cosine. What's this one?
Cosine.
Cosine times tangent. Yeah, cosine x times tangent. Can we do this Can we do this derivative? Because we have a product rule. Can we do this derivative? No, because we don't know what to do when there's a whole ass function inside of another one. We don't know what to do with that yet. That's section 3.4. And that's the title of 3.4, whole ass function inside your function. What do you do? That should be the title. Yes, there we go. So now coming back to this, x cubed is happy down there. See how he's positive? If I force him up, he becomes negative. Okay. That's my highly hypertechnical explanation. See how I didn't put a prime? Because I haven't done a derivative yet. Now I'm going to put a prime. And what do you get?
12x cubed minus
12x
12x plus 6
2 comes down.
X to the negative
3/5
2.
comes down.
6/5.
Yeah.
6/5.
3 minus 5
to
is
negative 2/5
negative 2 over 5.
plus 9x to the negative 1.
Negative 3 comes down, makes it plus 9. And then you take the power down by 1. Okay, let me stop. Every single one of those has a devil inside. No, every single one of those has the exact same rule. Yes? They're x base to a constant power. So the rule is the same for each of those. Whatever the power is comes down, multiplies by whatever's there. The power goes down by 1. That's the rule for that. Okay, I like it.
Wait, for the third one, you have to do both product and quotient.
Oh, wait, you mean the third problem?
Yeah,
Alright, hold on,
for
we're
C.
No, we don't.
Right?
Nope.
Oh, okay, we're just leaving
Alright.
the 3. Okay, got it.
What do I have to use for this guy?
Quotient.
Quotient rule. Guys. Thank you. So what gets me started?
You have 3 to the x prime
Good.
times 2x plus 3 minus 3e to the x times 2x plus 3 prime
All
over 2x plus 3 squared.
Good. Alright. You've got to fight with yourself not to kill 2x plus 3 anywhere. Especially not this one, because that ain't 2x plus 3 anymore.
Mm-mm.
Okay. So G prime is, what's the derivative of 3 to the x? Holy shit, I'm gonna go ahead and distribute it, okay? I'm gonna get minus 3 to the x times, what's the derivative of 2x plus 3?
2.
2! Never forget, derivative just means slope. So if I say what's the derivative of 2x plus 3, it's the same thing as saying what's the slope of 2x plus 3. And the slope of 2x plus 3 is 2. Okay. All over this business. And then, do I have any like terms? What is this? 60 to the x. And I take that away from 90 to the x. So
But
I
you
end up-
can, but if you multiply the 2, then the 6.
This is 60 to
Oh,
the x.
Never
And if
mind.
I take that away from 9 e to the
Never
x,
mind,
I
never
get 3 e to the x. You guys okay with that? There's a, yes.
Would it be better to factor out 3 e to the x? What is that?
I mean, you could. Yeah. It depends on what's next, and there's nothing next. But if my question was, where's the tangent line horizontal? What does that mean? Tangent line horizontal. Where's the slope 0? And when would the slope be 0 here? If the top is 0. If you factor the top, I can see where it's 0. So it kind of depends on what comes next. And if nothing comes next, it doesn't matter. That's the, if you factor 3 e to the x, it will only be wrong. No, that's beautiful. Cheers. But I don't need to. Okay, yeah.
So, it's fine if we leave it in the factored form?
Yes, you can take a 3 e to the x out, and you'll have 2x plus 1. Yes?
Yeah.
Okay. If you want to. You leave your friends behind.
So the derivative of e to x, the number in front of it also, like, goes with it, like. you know,
Yeah,
but
so
the
watch
e to
this,
the
guys.
x-
Here's a general thing about constants and derivatives. Oh my gosh. I'm gonna get an iPad. I think I told you guys this, I can't remember.
No.
I need to get an iPad so I can walk around the room, I can wirelessly connect, I don't have all this frickin' paper,
Yeah.
and I can save the PDF and the notes and upload.
Yep.
That's my goal.
Some teachers scan the notes at the end of class and upload them to campus.
That's the good teachers, let me alone on that.
iPads are on sale
He
right now
goes-
for teachers
Yeah.
and students, and before the end of the month, you get a $100 gift card.
So I want you to realize, David's like, dear God, do that shit. I appreciate that, okay.
He's doing,
Dang it, what was
he's
I just about to
recording
do?
the lectures.
Shoot, I forgot what I was
Got that going.
just about to do.
You were showing us something that was like
Constants e to the
basics to for constants and, no, for.
'Cause I asked about the e to the x of 3, why does it?
Oh, yeah, okay, thank you.
Yeah.
Guys,
eventually got
help me
there.
out, 3x squared, what's the derivative?
6x.
Did you give a single thought about what the 3 is doing?
Nope.
No.
Nope, the 2 came down and made it frickin' 6. So what do constants do? They come for the ride. That's all they do. Now let me really analyze this, you ready? So if I had 3 e to the x, and if I view that as a product, it would be 3 prime e to the x plus 3 e to the x prime, yes?
Yep.
Yeah.
What the hell is any constant derivative?
0.
So this whole thing is 0. So what we've done is we just kind of made a shortcut out of this. If I see a constant multiplier, it just comes for the ride because its product rule piece would always be 0. So it just comes for the ride. We sort of build that in from the beginning. But it's a really good question, and it gets a little confusing, I understand that.
I don't like the next one.
All right, last one for today.
No. No.
All right, guys.
No.
Guys. What was the answer to part B?
Oh, 0.
Why?
0.
It's
Because
constant.
cosine 2 is a constant. Do I see any variables
No x's.
on the right side?
Oh.
E is a constant. Pi is a constant,
Yep.
yes? So isn't all that shit just a number?
So we just,
So what's its derivative?
wait,
Another way to say it
wait.
is, go ahead.
Wouldn't that be an indeterminate form? No, because it's not a limit.
There's no limits, the bottom is not 0, it's just
But
whatever the hell that is.
You can't do 0 over 0.
It's not 0 over 0.
It
Okay.
is because pi
Listen.
is a constant.
No,
And
no. If I have a quotient, guys, if I have a quotient, do I just do the derivative of the top divided by the derivative of the bottom? Do I ever do that? I never do. The derivative of parts of something all at once. Every rule we're gonna learn, parts get their own term. So I'm not gonna do the derivative of the top divided by the derivative of the bottom. No. I'm gonna realize that this whole damn thing is a number. If I plug this in my calculator, I get a number, correct? And what's the derivative of any number?
0.
There's no rule for anything, it's all constant. There's no variable dependence. So if I let x change, how much does y change? In part D.
Doesn't care.
Does not.
It doesn't give a shit what x is doing. There's no x in there. I have no control. It's its own number for a little d. So when I take its derivative, it doesn't change, so it's 0. That's plenty. All right. I'll see you guys Wednesday or before that if you want to come by for office hours. Come on up here if you have any questions.